myself Jaishree Jain from AKGEC Engineering College, Assistant Professor in AKGEC Engineering College. So today we will learn about the fundamental gray level transformations in image processing. So the gray level is what when we have an image of any size, and there are three features in the image. We have x coordinate, y coordinate, and the intensity. So the gray level is what? Gray level is the intensity of the pixel. So we have to just before applying the any filter on the image, we have to just transform the image pixel so that we can process on the pixel, we can compress the image, we can apply different filters on the image. So we have to perform certain transformation. So we will learn today what are the different gray level transformations. So basically we can say all image processing technique focused on the gray level. So basically for research purpose, we can say images are used in the grayscale images are generally more flexible, and we can apply different operation easily on the gray level image, and gray level images we can say are more secure rather than color image. So we can easily perform various functions on the gray level images. So we can say it is mainly we focus on the gray level images. So we can say the intensity of gray level images are from 0 to 255. So we have range of the pixel from 0 to 255. 0 means black and 255 means white. Fine. So horizontal axis we can say spans from 0 to 255, and vertical axis depend on the number of pixel in the image. So if we draw one histogram, we can draw the intensity of the pixel. So we can find out how many pixel are of 0 intensity, how many pixel are of 1 intensity. So we can plot the histogram, and from viewing the histogram, we can see the distribution of gray level in the image, how gray levels are distributed in which manner in the image. So we have to follow, firstly we have to calculate the intensity of the gray level images. Next is the conversion. So we have to for image, actually why we are learning this transformation? For image enhancement. So for image enhancement, we have to just transform our image into into the another form. So that enhancement means we have to increase the brightness or contrast in the image. We can apply different function, like today era we have different applications. Also we can crop, we can increase the image enhance brightness or sharpness or contrast. So there are different transformation techniques. So this is a formula, this is a basic formula. If we have the initial image, that is we can say that is R, and here we apply any transformation function T, and we can apply transformation function T on that, and we will get the transform image, that is S. So T is the transformation and R is the value of the pixel. So this is the basic formula for transforming our image. Now we have to calculate this T, what kind of transformation we will apply on our image. So we can say there are two parameter R and S. R and S are used to denote the gray levels of the image of F and G. Means we have the two-dimensional image. R, X, Y means X is the horizontal axis and Y is the vertical axis, and the intensity we can denote intensity at XY. So we have two kind of pixel, that is reflection. R is the original pixel and S is the transform pixel. So we can say original image is FXY and transform image is GXY. So we can represent this R with FXY and S with GXY. So this is the simplest formula. Now there are basically three types of transformation: linear, logarithm and power law transformation. So we can, here there is a diagram, we can see here what is the effect of the transformation on that gray level image. So what is the effect? We can see here linear transformation means we have no change on the image pixel intensity. There is a graph, like this is a straight line, this is linear plot. So this is, we can say, this is a identity matrix. So we can say image pixel remain the as it is, the value of sxy, the value of gxy will be the same as the fxy. So this is a linear transformation, and in logarithm transformation we have to take the log of the on the image pixel value. So when we take the log, we can say here this is a input gray level intensity, and on the y-axis we have the output gray level intensity. So at the input level gray intensity, here we have the intensity L by 4. So here we have the intensity L by 4. And here we have intensity L by 2, and here we have 3 L by 4, and here we have L minus 1. So first is the L by 4. At L by 4, when we take the log, we get the value here. We can plot here. At this L by 4 value, we get this value. And at L by 2, the output gray level is that. And at 3L by 4, the output gray level is that. So this is the point actually. This is the point. So this is, here we get the value that is transform value at L by 2, at L by 4, at 3 L by 4. So here we get the different value at log graph. Fine. So these are the values. So we can say, so what is the result actually? Linear transformation actually means, we see here one by one. Linear transformation means it includes the identity transformation and negative transformation. So identity means image pixel remain the same. What is the input grayscale? Same will be the output grayscale. And when we talk about the, this is the identity. So here the value of intensity is 127, and here is the intensity is 127. So this is the identity transformation, and next is the negative transformation. As we know, in when we capture any photograph, then the negative will be stored in the camera reel. So this is a negative transformation. We can say, then when, how can we calculate the negative transformation? We have the original pixel value R, and we have the L minus 1 is the, L is the size of the highest intensity of the gray level. If we this is the image, input image, and if we can take highest intensity like 255, so 255 minus 1 or we can say 250, total 256 gray levels are there. So 256 minus 1 minus R means 255 minus R. So this is the formula for negative transformation. It means when we subtract this original value from 255, we will get the value. That value is when here we have black will convert it into the white pixel, and white will convert it into the black, and different shades of the gray level will, if it is a have high contrast, then will convert it into low contrast value of the intensity. So negative means opposite, means we subtract from 255 and we will get finally the negative of the image. So this is called as a linear transformation. Next is the logarithm. Logarithm transformation is what? When we have actually logarithm transformation is also divided into two parts, log and inverse log. So what is the formula for log transformation? S equal to C log R plus 1 means we have to take what is the original value of the pixel, that is R, add 1 in it and calculate the log. So this is the formula, C log R plus 1, and C is one constant here. So we can say S and R are the pixel value of the input, R have the input pixel value, S is the transform value, and A and C are the constant. So C kya hai? C is the constant. So in this formula we can see 1 is added in the each pixel value. Now question arises, why we add 1 here? Why we can't directly write C log R? Fine. So why we have added 1? Because when we take the log 1 means 0. So the value of pixel will get 0. So we have to prevent this. So if we add 1 to each pixel, this is because intensity will get 0. So pixel will vanish. So the value will get loose. If the image log 0 is, and log 0 is what? Log 0 is infinity. So here if we have the first value 0, log 0 will get infinity value. So we have minimum value 1, so log 1 equal to 0, and we have first value is 0. Fine. So this is called as log transformation. So this is the outcome of this image. We have input image, and when we take log transformation, we get this output image. So here we can see here I think contrast is more. So when this image is dull, we converted or transform take the log transformation on this image, then we will get the final image, and this image I think have the high contrast value. Next is the power law transformation. Power law transformation is what? This is a formula. How can we calculate the power law? In which we have one parameter, that is gamma. So we put r raised to power gamma, and c is same constant. So gamma is what? Depending on the value of gamma, if gamma value is less than 1, then changes darker to the brighter image. If we have very dark image, so we can take the power law transformation and have the value of gamma less than 1, then we will get the brighter image. And if gamma is greater than 1, then we have to choose, then the outcome of the image will be more, we get the darker image. So this is a formula for calculating the power law transformation. Depending on the value of gamma, if we want more brighter image, so value should be less than 1. If we want more darker image, then gamma should be greater than 1. So this is a formula, and here we have different values of gamma. So we can say at different point we get different intensity. Gamma 0.67 here, and if gamma equal to 1 means identity हो जाएगा, and gamma 1.5 means we are reaching to the highest value, means we will get the high contrast image is gamma is greater than 1, darker image. Fine. So, and if gamma is less than 1, then we will get more brighter image. So this is the outcome. Here our intensity is getting below, and if gamma is 2.5, we have value L by 2 at this point. Fine. So we get more gamma greater than 1 means more darker image. Darker means it will be more blackness will be there, and if we are saying more brighter image, then it is reaching to the whiteness of the image. So so we can say this gamma transformation means images that are not corrected properly look either bleached out or too dark. So I already told, if we capture some image and it is too dark, so we have to take the transformation. We can apply power law transformation on that image, and we will decide the value of gamma. According to the value of gamma, we can find out the brighter or darker image. So various gamma changes not only intensity but also the ratio of red to green to blue in a color image. So if my image is colored, so if we are taking the power law transformation on colored image, so we can say it is going to transform from red to green to blue. Means red color intensity, we know intensity of red color is very high, so it is converted in red color to green or blue. So gamma correction has become increasingly important as the use of digital images over the internet. When we are going to share digital images over the internet, then we have to actually, some distortion will be there, some noise will be there on the channel, so our image get degrade. So we can enhance the image intensity by applying the power law transformation. It's useful for general purpose contrast manipulation. So if we want to manipulate the contrast, then we can apply this transformation. Apply the gamma correction on CRT printers and scanner. So this transformation can be applied on different media devices, and gamma value depend on the device. So it depend on the device. If we are transforming the image onto the CRT. So we have to maintain the darker image so that it will be display on the screen with highest colors or with the brightness. So it depend on the device from which device we are going to use or send the image. So according to the device, we can change the value of the gamma. So earlier diagram can be divided into 3 categories. So their gamma value can be vary from 1, less than 1 or greater than 1. And we have take the example of CRT. CRT have the gamma value varying between 1.8 to 2.5. So depending on the device, which value we are going to take. So here we can say if gamma value is equal to 6, there are different example. If gamma is equal to 6, then image will be in this form, and when we choose gamma equal to 8, it is more darker image. Gamma equal to 10, it is more, background will get more and more dark. This is another example of power law transformation. If we have gamma value less than 1, it will change darker to the brighter image because it have the value less than 1, so we will get the bright image. So here we have gamma value 0.6. This is the original image. When we apply power law transformation, it will have brighter image, and if we have gamma equal to 0.4, it will convert it into more bright image, and gamma 0.3, then we will have more bright image. So gamma correction, next is gamma correction. Gamma correction is what? When we have to actually, it depend in which device we have to send the image. So generally we have to apply the gamma correction on the image according to the device. So selection of the device, when selection of device have going to vary, then we have to correct the value of the gamma. So it is very important. So simply by applying the transformation, simply we have, if we have the gamma value 1 initially and we are going to send this image on the CRT device, then we have to correct it by 2.5. So this is the value we have chosen for gamma correction. Divide it with the original value, then we get updated value r raised to power 0.4. Means we have to apply gamma value 0.4 so that we will get the correct image displayed on the screen. So gamma correction is important for displaying image accurately, required for further analysis and decision making. Means for research purpose and for transformation purpose, we have to apply correct the gamma value so that we will get the accurate image, and the value of image intensity will be accurate. So this is very important. Next is gamma correction. This is example of gamma correction. If we have this image, this is the original image, and this is very dark image, so we have to dilute image into some shades of gray level. So we will transform it and original image as viewed on the monitor. If we transform this image on the monitor, it will get more darker. So this darkness is very so we have to remove this darkness. So we have to apply the gamma correction. When we correct the gamma value of the original image, then we transform this image on the device, then we will get the accurate image. So this is one example of gamma correction. Next is piecewise linear transformation functions. So previously 3 transformation will directly apply on the whole image, but if we want to apply some enhancement on the particular part on the image, means if we have image size is 256 by 256 and we want to enhance the contrast only on the block of 32 by 32 pixel, then we have to segment the image and apply the transformation on that particular block only. So we have to just perform the piecewise, means we have to divide the image into different blocks and then we apply different method on that block so that we can enhance only the particular section. So first is the contrast stretching. Contrast stretching means its name suggests contrast, means it is it will focus on only the contrast of the image. So we have low contrast image, we have high contrast image. So contrast stretching means when we see any image and we found any block have the low contrast, then we can enhance the stretch that contrast into the convert that interest into the high contrast image. So low contrast image can result from poor illumination. Actually, what is the source of low contrast image means when the sunlight is very low, we are going to capture any scene via our camera, digital camera. So we will get the low contrast image when illumination is very poor. So lack of dynamic range in the imaging sensor means when we are going to capture any image with the help of sensors, so there is a lack of dynamic range. That sensor is have the fixed position, or the area or span of the sensor is very low. So image we will get low contrast image at that section. So dynamic range is low, or illumination is low, or even the wrong setting of lens aperture during the image acquisition. So these are the reason why we get the low contrast image. It expands the range of intensity level of the image. So it spans the full intensity range of the display device. So basically purpose is what we have to enhance the contrast of the low contrast image into the high contrast image. So this is a formula for contrast stretching obtained by setting R1 S1. Actually we have piecewise transformation. So we have the lower range from where we have to start, that is R1 S1 point, means R1 is a input image and S1 is input contrast, or that is S1 is a output contrast. So R min comma 0 and R2 S2 will be converted into the R max comma L minus 1. So contrast, how can we obtain this value? It is a process that expands the range of intensity level of an image. So when we enhance the intensity of the image, contrast will get enhanced. So we have to actually, what we have to done, we have to enhance the intensity of the image. So it expands the full intensity range on the display device. So statistically, contrast is obtained by computing the variance of the intensity value. So firstly we will calculate the variance. Variance is what? That is sigma. So low contrast image have the low value of variance. If the contrast is low, variance value will be low. So while acquisition, low contrast image may result due to the improper and poor illumination. We already studied this, wrong camera setting, lack of dynamic range of image sensors. So these all are the reasons. So this is a formula for getting the high contrast image, S equal to S min plus S max minus S min divided by R max minus R min into R minus R min. So this is a value where we have intensity minimum, original intensity range is R min to R max, where we are getting low contrast, and we have to map this value into the S min and S max where we get the high contrast value. So two variants are there, range normalization and intensity or gray level slicing. So in contrast stretching, we can normalize the range. First application is what? We can normalize the range from min to max, and intensity or gray level slicing. Second transformation is intensity or gray level slicing, where we can apply this. So this is an example, how can we apply it into the range normalization. So we have the intensity value, for example, we have 0 to 7 intensity value in an input image, and pixel count is number of pixel having 0 intensity is 0, means there is no pixel of 0 intensity, and 1 intensity pixels are 5, 2 intensity pixel are 15, 3 is 0, 4 is 20, 5 is 0, 6 is 20, 7 is 0. So this is the mapping table for contrast stretching, means we have 6 intensity, 1, 2, 3, 4, 5, 6. These are the intensity 1, 2, 3, 4, 5, 6. Fine. And we have to convert, this value is 0, this value is 0. So we eliminate these values and range goes from 1 to 6. Then we have to map this value into the high contrast value. So we can say this is a mapping table. Now see here, here we have value of 1, we convert it into the value converted value is we take the transform value 1 corresponding to 0. For intensity 2, we will convert intensity 2 into the 1. This value actually occur with this formula. We have to put this value into this formula and we will get the value of S min and S max. So S min is 0, S max is 7. We have to map these intensity from 0 to 7. So we will put the value of R here, and S max and S min are 0 and 7. R max or R min is 0 and 7. So we put value in this formula, we will get the mapping table, and with the help of mapping table, we will finally convert it into the high contrast value. So first is intensity value is 0. Intensity value is 0 with corresponding the correspond to the 1. So 1 intensity value 1 having pixel count 5. So here 0 will map into the 1 and 1 have the pixel value 5. So 0 have value 5. Then next is 1 map with the 2 have the 15. So we will get here 15 pixel count with the value 1. So next is 2 is 0. So value is 0. 3 is 3 correspond to 0 pixel count. So here we get the value 0. And with 4 we have same value 20, and for 5 is 0, 6 we have 20, sorry 6 map with the 5 we have 0, and next is 7 will map with 6 we have the value 20. So we will get this value in the this is called as in range normalization. This is very important question. So when we apply contrast stretching, these kind of question can come. So we have to change this value from low to high intensity. So these are different example, like piecewise linear transformation function. Here we have the input image, and we have only want to contrast stretching in this area. So we have R1 S1 and R2 S2. So this is a transformation we apply only in this region, and this will remain the constant. Fine. So this is a contrast stretching example. So firstly we have form of transformation function, next low contrast image, next result of contrast stretching, and next result of thresholding. So we will get, this is a low contrast image, we will get high contrast image, and we can apply threshold here. So we can compare the pixel, and we will convert this image into actually in black and white image. So high gray level will convert into 1 and low gray level will convert into the 0. So this is an example of contrast stretching. So next is intensity level slicing. In intensity level slicing, so thank you so much. This is we have completed this lecture. Thank you.